Hello! Are you ready for a theory about Steven Universe? Because I am. Because I'm recording one right now, and just finished a ton of research. So, Lapis Lazuli is completely overpowered, right? If you don't know this, then this is your spoiler warning. So, I did the math, and I figured out exactly how overpowered Lapis Lazuli is. And trust me, you might be a little shocked. Here, I show an intro, which I made myself. It's not really good, but people show intros for some reason. I don't know. I'm doing this because this is what you do. Okay, so we know that Lapis was able to lift the entire ocean. That's a ton, right? So, I did a quick Google search, and it turns out, well, it weighs a lot. One, and then 450, and then 5 bunches of zeros. That's a lot. And that's just in groups of 2,000 pounds. So that was measured in tons. Alright, so I multiplied it by 2,000 to get the number of pounds, and just look at that number. 2, and then 900, and then just look at that number. Jasper is known as the strong one, and that's how much Lapis can lift. Well, how can we take this further? How overpowered would Lapis be if she were to weaponize this ability? So, the first question is, how will she be using this as a weapon? Now, we know that she was able to use her water wings in space without her wings evaporating, so we can tell that water under her control does not succumb to the void of space and evaporate immediately. So, let's say that she drops this giant pillar from space. This makes finding out how much force is driven behind this giant pillar of water by the calculation of force equals mass times acceleration. Acceleration being the terminal velocity, which is the maximum amount of speed something can go while it is falling. The first part of my terminal velocity formula requires an area, the area of the surface facing down. I got 14.137 since this is a cylinder and it's a circular shape. And I estimated that the diameter was 9 meters across, so this is the area I got. And I'll show you a video in a second how long 9 meters diameter is, and it's about the size of the area that Steven and Lapis were talking on. So for scale, 9 meters is 29 and 6.333 inches. So from here, this stick, to over there. Now, it looks pretty big in this camera, because the camera's small, and that's just how scale works. But, it's actually not that big, and about as large as it was depicted in the show. And here, for reference, is a picture of Lapis and Steven sitting on what, now looking back, was actually a pretty large space. Okay, so I put it into a terminal velocity calculator, and the speed this giant pillar will be falling at its maximum speed is 3.48803 times 10 to the 10th power, which is pretty big. Let me show you that number. Alright, so traveling at a speed of 34,880,300,000 meters per second. And remember, that's not like miles per hour, or it takes an hour to go that many miles. This is how many meters it's going per second. That's really fast. Next is the mass part of the formula. And as you can see here, in order to get your mass from your weight in kilograms, you need to divide your weight by 9.8. But this only works if you have your weight in newtons. Currently, we have our weight in pounds. So, I obviously next found out how many newtons our number was. Alright, so here we have it converted from pounds to newtons. However, we don't get to really see the whole number, so let me put this number in a note by copying and pasting it so we can see the full number. This number is ginormous, okay? So this is 1.28998426400, a bunch of zeros and a 7, times 10 to the 22nd power. Now let me type that out as all of the zeros showing. Let's just appreciate this magnificently large number for a second. Alright, I'm putting in the numbers. We have our mass to the left times our acceleration to the right. Now let's see. Alright, so if Lapis were to lift that ginormous pillar of water into the sky and drop it on you, this is how much force it would have on you. To help you understand, I'm not going to use how many bullets this would be. I'm just going to explain it to you directly what it means. So what Newton feels like is what the weight of that number feels like. So, yeah, if you had 4499503812359920244162101 sorry 0.000000000 newtons of weight on you, yeah, I'm pretty sure that could break any sort of gem that you might have, and depending on how strong of a bond artificial fusion is, that may or may not be powerful enough to break the cluster. Yeah, with the drill that was described as small for scale, the cluster looks small enough that this might be enough force to at least make a huge dent in it. But why didn't Malachite use this amazing power against the crystal gems? I hear you asking in the comments section. Well, it's simple. Because at this point, when Jasper... Yeah, I'm just going to call it Malachite Jasper in this case. Jasper is not the sharpest gem in the gem store, honestly. Peridot, if Lapis fused with Peridot, maybe, then she would know to use that much power, but honestly, Malachite was just like, oh, I can control water. Obviously, I'm going to make water weapons and pretty much do my weird Sonic Dashy thing that I pretty much always do. But wait, there's one more step. So, I do have another Steven Universe theory in the works, so you should like and subscribe. It's pretty much on the effects of fusion, whether or not Steven can fuse. It's pretty much like a fusion special, honestly. Plus, I do have a Pokemon thing as well, which I think is cool. And also, by the way, I'm testing out a new microphone right now. This video was done with it. I got it at a garage sale. And I would like you to actually answer this card, which is coming out of the corner, on whether or not you liked my microphone quality and whether or not it's an improvement on what I usually do. Bye!